I am 61, almost 62 years old. I'm much more aware of the fear of falling.
Okay, ready? Yeah.
I'm more aware of trying to challenge myself in different ways to stay active, both mentally and physically. It's just part of getting older and not having the flexibility, the stability that we take for granted until it's not there anymore. My name is Elizabeth Christopher, and I am a research participant in the Jason Franz lab at UNC-Chapel Hill.
Preserving independent mobility for people in our rapidly aging community is more important than it's ever been today. The number of people that are over the age of 65 is projected to increase and increase. My name is Jason Franz. I'm a professor of rehabilitation engineering in the Lampe Joint Department of Biomedical Engineering here at UNC-Chapel Hill and NC State University. And so there's an urgent need to engineer solutions to ensure that older members of our communities are able to participate in the activities that they've always strived to participate in, maintaining their independence, living in their homes as long as possible. We really are committed to understanding the why behind the way that we move, the why behind things that might go wrong. The why do we walk slower? Why do we fall? Why do we get fatigued? And why do we have pain when we move? And by understanding those whys, we as engineers are uniquely trained to potentially come up with solutions to help those people in the community.
As I'm getting older, I find that I do kind of trip on my foot every now and then, just walking on outside or something. And my mother has experienced a couple falls, and she's 90 now. And so I want to avoid that in my future.
The mission of the Applied Biomechanics Lab is to engineer solutions to help people age gracefully. When it comes to falls, we've developed paradigms that allow us to challenge balance and the safety of our laboratory. Some of those are the virtual reality system. Some of those are robotic systems that pull on us in different ways, or ways that our treadmill can emulate slipping on ice. Around the lab, you'll see three-dimensional motion capture cameras that can track movement. We can measure the neural signals coming from the brain through EMG sensors, wearable sensors. We also have video X-ray, which allows us to look inside the joints and see how are the joints executing movement. I've been at Carolina for 10 years, and one of the most exciting things to do is have conversations with our research participants, people in the hospital, people in the community, and figure out what their needs are, but also to learn how to describe the research discoveries we're making.
I am glad that there are studies like this to keep everyone safe as we age.